Welcome. This is our third modding bootcamp on modeling with our character artist, Antonios Koutsouradis. So in this bootcamp, Antonios will be focusing on importing assets to Workbench, rigging them to skeletons, and character modeling in general. Let's kick it off, and I'd like to welcome Antonios to the stage.
So to start, one of the first parts of creating a model is the Highpoly. We're using zebras for this, to start the Highpoly. Inside the documentation, we're basically following this documentation to the letter. So inside this documentation, you will find what you need to start. So what I have here is basically the character head that exists inside Reforger, and that is basically found here. If you open this, you will be thrown into the GitHub page, and from these three dots here, you can download the file. So once that is done, the model is imported here, and we start the modeling process. Some small hints on how this was started. Zebras provides some very nice sculpting tools. Like the first part, the casket of the helmet, like you can easily just mask part of the head and extract it and start shaping a helmet. It gives you a shape like this, and then with some easy modeling tools you start shaping in it, and slowly the body of the helmet was modeled. Unfortunately, we don't provide access to every single one of the heads, so the straps cannot be perfect. Just make sure it is floating just a bit from this head and you should be fine. After the main modeling is done, you see the topology is not the best, and this kind of model it could be imported inside Infusion, but a high try count will slowly make the performance of the game degrade. So the next part of the process is to create the Lowpoly. Now when we want to export this model, Zebras is generally very performant. You can have some extreme poly counts in the models. This at the moment has 4 million triangles, and it's just this part. The whole model is much bigger. What we use to reduce the topology so we can import it on some other software is Zebras provides this decimation master plugin, which takes the model and decimates it down while trying to keep most of the detail that you see here. What we end up with is basically this. This, as you can see, is very crazy topology, but it keeps most of the quality of the asset, so we can then come on top of here and model the Lowpoly. Again, not all of you might be able to follow this process because not all of you have access to Maya, which is understandable. Similar plugins to how remodeling works in Maya exist for Blender, so with some search you might be able to find it. How the retopology happens inside Maya is we're using this tool that we call Quadro. What Quadro does is basically you can configure a surface. Now I've configured the faceplate of the helmet to be a live surface. What this does is Quadro just snaps the points on top of it. So now you see I've placed 2 points, and because I'm using symmetry, they've appeared on the other side as well. And if I connect 2 more, and with shift and click, I can create a face. And then with this, you slowly go around and you create the whole topology of the helmet. Now I've gone through and I've done the retopology so that we don't lose time during this process. What I've ended up with is this. Generally good topology for something like this. It, of course, won't be animated. It's a hard helmet, it's metal, but you still want some nice topology so that you can do the next step, which is unwrapping the UVs much more elegantly. Parts that could be animated, like the straps, you would of course need a bit more clean topology. What clean topology means is that triangles are really not that liked. So as you can see here, I have like some perfect rectangles here that will deform pretty good. Like just as a showcase, I can try deforming some of the triangles here. And it generally deforms as expected. So yeah, after this, what we're thrown into is the unwrapping. Blender also provides a way to unwrap the model. It's a bit similar to this, with Maya has some better tools, but again the same level of tools can be found through some plugins in Blender. What I've done here is to save some space for myself, because as you can see here, every part of the topology is being laid flat. That's basically what the UVs are. You want to lay them flat because this is what the engine is going to read, and this is where the texture is going to be applied, and then based on these coordinates the texture will be applied on the model itself. So whatever exists here on the texture will be applied on the same place on the 3D model. Now I've done some economy UV unwrapping here. What this means is that you will see this island, as we call it, the UV island, is on the external part of the face shield, and the internal part is this. You will notice that the internal part is a bit smaller. That will give it a bit less resolution, but since this part won't be very visible, I can shrink it just a bit so I can save some space, so I can enlarge the other ones a bit more, so I can get some more resolution on the outer side. The same has been done for the inside of the top of the helmet. In general, that saves me a lot of nice UV space, so I can take advantage of it on places that will be closer to the camera or more visible. So with this part out of the way, now we have the low poly. In general, in most engines that work for games, rendering models in real time, having the best topology always on the scene is a bit too expensive. So a nice technique that is used in games a lot is LODs. What this means is that when the model is closer to the camera, the bigger model is going to be used with more topology, more expensive to render but better quality, and the farther away from the camera it will be moved, it will slowly switch into the other LODs. These LODs, there are ways to automate this process, but in general I found that it is nice to do it yourself. It doesn't take that long. Again, there are some nice tools in Blender to perform this task, but the way that I do here is that I'm using basically welding points together, so I can slowly decrease the topology. What I want to aim for usually is that once I go down one number in LOD or up, however you see it, like LOD 0 is in most engines the biggest model, the more complex one. LOD 1 comes next, has a bit less quality, LOD 2 comes next, has even less quality, and LOD 3 even less, and you can go as far as you want. We usually go like to either 3 or 4 extra LODs, depending on the complexity of the asset. If the asset has too many triangles on its LOD 0, and we are allowed by this number to go below like even an LOD 3, we might take that. So going from LOD 0 to LOD 1, it is nice to go for a 50% amount. Now I have like the try count here. What a try count means is basically the amount of triangles. Here you see squares, you see a polygon. So the number here is basically for every polygon there is like 2 triangles. So imagine the software just cuts it in and it counts this as 2. So LOD 1 has 3108 triangles. So for LOD 1 I want to go like 50% of that, and this is what that looks. the way I ended up in that is basically by welding points. There is this tool inside Maya, the target weld, I can use to select points and weld them together. So slowly, like I go and I remove topology from where I want, from where I deem that it is too much for an LOD1. So the process can be a bit slow depending on the asset, but artist authored LODs are always the best. Again, there are some tools outside that you can automate this process with, but making stuff by hand is always best. So you can see here LOD2 goes around 50% below LOD1, and then LOD3 goes all the way down. This is the last LOD, so I try to go as low as I can. So imagine this is LOD3, so it will be viewed from a distance, something like this, and maybe even more. So all the characteristics you might want to try to keep will not be visible anyway, so you might as well delete the topology altogether. So this is it pretty much. Once you've reached this point, you basically have your low poly. This is what will be used to be brought inside the game. After, of course, you have completed the UVs, you are ready to do some baking. What the baking is, basically we will take the nice quality detail that we have from the asset and we will bake it on a texture that we can then use to texture the asset itself. In this part of the process, you could also take the time to create the collider of the asset. It can happen later in the process, but it can be done here as well. What the collider is pretty much is nothing in the engine can actually collide with a model. You need to provide actual geometry that will be used as a representation of that shape that will take, for instance, this is a helmet, so this is the shape that will say if a bullet has hit the helmet or not. What the collider needs is, it needs to be quite low in topology. We really don't get anything from extra topology here. If the shape is descriptive enough of the surface you're trying to describe, then you're good to go. Like a topology of something like this for a helmet is pretty good. You can go even below that, but something around the hundreds is pretty good. I want it to describe the face shield, so if somebody gets shot here, it will stop the bullet. We can go a bit more descriptive and like put a hole in the eyes, but that's too much. So yeah, after that is done, we need to go to the baking process. What I'm using for the baking process, and we're also using it in the studio, is Marmoset toolbag. Provides a lot of nice functionality for us. One of the functionalities that I can separate parts of my model so that I don't have baking bleeding between them. So for instance, parts of the asset like the face shield and the helmet that are way too close, you might get some bleeding in the baking. Why that happens is basically because there is a projection happening. For every face on the model, on the Highpoly, there is a projection happening along its normals on the Lowpoly itself. It's basically a million different cameras taking pictures from the model on every angle and pasting it on the UVs of the Lowpoly. So the final texture that we will get from the baking will look similar to this. The details will be laid on top of this. So what this looks like, at the start it should look something like this, like I just imported my model inside of here. If I hide it, you will see. And now I have just my Highpoly visible. This is the Highpoly that I've exported from ZBrush. This is pretty much the same model. And what I want is to project the detail that this model has onto the Lowpoly that I just created inside Maya. What maps the Marmoset toolbag allows us to bake are listed here. What I want from this, what is useful for me, is the normals, the curvature, the thickness, and the ambient occlusion. Optionally, you could get a material ID. What a material ID mask is, I could give different colors to parts of my model. So I could do this green, and I can make this red. And then I can get this as a texture inside of my texturing software, so I can mask out easily parts of the model. So if I want to apply a texture just to the face shield of the helmet, I will be able, by using this mask easily, I will just be able to tell the software just do it on anything that is painted green. That is a nice mask to have, but on this specific asset, everything will be one material except for the strap. The strap is already a separate geometry, so it will be easy to mask it out anyway. What is important here is when you bake the normal map to flip the Y, if you, of course, are using Substance Painter. Substance Painter is using a different normal map orientation than Marmoset. So if you're using this combination of software, it is you should be flipping the Y. What this does is basically they have an opposite direction of normals. In Marmoset, I think Y up is white, and in Painter it's the exact opposite. So what I end up with in the end, I just added the maps here on the material so we can easily see them. Basically the normal map just gives me all this lighting information that exists on the Highpoly. If I make this metal so we can get some nice reflections, you will see it. If I remove the normal map, nothing is there. That's basically the normal map. The occlusion basically gives me the shadows. I would be getting a shadow inside of here if I hadn't separated everything into different pieces, but because I want to create a variant where the face shield is open, I have prepared the geometry here. If I didn't want to do that, I could bake the ambient occlusion, so I could also get some nice shadows in here, which I could also throw some dirt onto. But since I want to have a different geometry variant with the same textures, then I decided to just not bake the ambient occlusion here, so I can have the same maps. Because if I would then open the face shield, there would be some weird artifacts here from the ambient occlusion baking. So yeah, after the baking process is done, I usually try to bake in the biggest resolution I can, so 4K here. And the maps that I'm getting are pretty much, this is what it looks like. This is the curvature map, and this is the normal map. After this part of the stage is done, like I just take all the maps that I've baked in Marmoset, so normal map, curvature, thickness, ambient occlusion, and material ID if I need it, and I throw everything into Painter. After everything is thrown inside Painter, the way you import a model is you create a new project. We're using the metallic roughness workflow, so you should be choosing this. If you're working on a different project, then there are a lot of options in here that you can choose from. We're working with this workflow. You can choose the resolution of your of the texture you will be working with. Like I usually work on the biggest resolution, and then there is an option inside of the engine to import the texture in a lower resolution. And it's generally best to export from Painter or any other software in the biggest resolution you can, and then lower it inside the engine. Inside here you add your imported maps. You can press add, and it will open the file explorer for you. You select all your baked maps, and after that is done, you will see them here in the file browser. The layout here might be different from someone who opens the software for the first time. I've changed stuff a bit, but inside here you will find your baked maps. So I have everything here: my ambient occlusion, curvature, normal, and thickness, and the material ID if I had one. After that is done, you need to find the texture set settings. If they don't exist anywhere, you will find them here, and you will need to plug in every map that you brought in on the correct spot. If you see here, they have the names. This is the ID map. There will be a curvature slot here, so you just take the map itself and you place it on the correct spot. And before you start texturing, one last step that you need to do is you need to bake the extra maps. What the extra maps is the world space normal, which is basically a normal map, but taking the local rotations of the asset and world placement into consideration. What this map is useful for is, let's say inside Painter there is a smart material which lays snow on every part of the helmet that looks towards the app, and it samples this map to do this. The textures in here that I created are not that interesting. I generally take one of the smart materials Substance Painter provides, and I just iterate over them. What the smart materials are is basically it is using all this nice information that you brought from the baking process, and it's creating a lot of details. So for instance, the curvature map, what the curvature map is basically is gray on spots which are very flat, and it changes to white when there is some curvature found. So this is basically a mask that Painter is using to lay stuff or to lay details on top. So after the texturing is done, you need to export the textures. The texture template that Reforger is using is we're using two maps. Those maps are called BCR and NMO. The names basically describe what exists inside of those maps. I can basically configure whatever I want inside those maps, but Enfusion is using this. What this is basically normal map. We're just using the X and the Y coordinates on the red and green channel. Then we store the metalness information inside the blue channel, and then the occlusion information inside the alpha channel. And then the BCR is RGB is the color information, and the roughness value is saved inside the alpha channel. You can visualize those inside here. So this is pretty much the roughness. This is what will be exported as together with a base color map. The metallic information is here, and the occlusion information is here, and all those will be exported into two different textures that you will use inside the engine. So yeah, with that out of the way, you are pretty much ready to start moving towards the engine. You have your Lowpoly ready. If you took the time to create the collider, you have that ready as well. And if you're already working inside Blender, you already have the asset inside Blender, and that's where the next step is at. If we open the documentation and we go to the part where we should be doing the rigging, you will also find another template here. It will also get you to the GitHub page, and with the same process here you download the file. I've already opened the file here and I have it open. This is probably what you might be seeing once you open the template. You might be missing the bone names, but that's not important for us at the moment. So once you open this, you should also open another scene in Blender. Delete this cube. What we want now is we want to bring in our asset. So just import the asset. So what I have exported from Maya is pretty much my LODs and the collider. What is important here now, first of all, is the naming. Once the asset is brought inside the engine, the engine will read the names and it will understand that these are LODs. The proper way to name those LODs is without this underscore between the LOD and the number. You should have an underscore before the LOD, but this is how it should be called. Helmet LOD 0 with no dash between the LOD and the number. If you import it like this now, it should read that these are LODs and they are not parts of the same asset. And then after that, the collider, since we are not using a base shape as a collider, You could have a UBX. A UBX is like a box collider. What we're using here is basically a tri-mesh. It's a triangulated mesh. There is a bit of there is documentation about the different naming conventions for colliders inside the Reforger website. So the naming convention for this would be what kind of collider you're using, in our case UTM, and then the name of the asset. It should have the same name as your LODs have. So once that is done, you need to go back into the scene where the armature is at, and you need to be very careful so you can copy everything. What we need here is the armature. We should be copying the body, it's not mandatory, but I will use it to transfer the weights. This body is already weight painted, so we will just copy all those weights into our own asset. So it is useful to bring it with us. And of course these memory points are important. If you forget them, it's not going to work once you put it inside the engine. So with control click, you select everything. And then if you do a control C, you will see here copied 8 assets. If I go back into my scene and I do a control V, it will paste everything here. So to organize the scene a bit, I can create a new collection. What this is basically is a folder. And I will take all my actual assets and I will put them inside this new collection so they are separate. I will hide the armature because we don't need it for now. I will hide this, and I will just keep visible the first LOD at the moment, LOD 0. So the way we're transferring weights, this is the first part that we need to do. The weights are basically called vertex groups inside Blender. They are describing the same thing. I want to select the model that has the existing weight paint, and then with shift click on the scene I can select my asset. After that is done, I can go inside here. I will change from object mode into weight paint mode, and inside the weights I will choose transfer weights. This will take all the weight paint from the base model and put it on the helmet. A setting that we need to choose is in the source layer selection. We go by name. On the right here you will see now we only moved one vertex group. We want to move everything, and choosing this option will move everything for us. Now we basically have weights on our model. What weights are, just going to skim over it. Basically the rig has bones on it. This is how the bones look. What weight painting basically does is it says for every vertex, meaning every point that exists on our model, how much influence each specific bone has onto it. So if we want a bone to move this vertex, if we want a vertex to follow a bone 1-to-1, meaning that if a specific bone rotates 90 degrees, this will also rotate 90 degrees. We need to have a weight painting for this bone to set to 1. Values on weight painting go from 0 to 1. They can go over 1, but we are normalizing before exporting them. What normalizing does is basically takes them, if the values are outside 0 and 1, it takes them and it compresses them inside 0 and 1. So if I isolate the asset and we go into weight painting mode, here on the left, on the right, we will see what bones exist in the armature. So the most important when you're making a helmet is the head bone. This helmet shouldn't deform at all, like it should just follow the head position and the rotation. So I want to make sure that most of its surface, if not all of it, excluding of course the strap, is weight painted on the head. So I can select on which which bone's influence I'm actually painting by selecting the bone here, and then by using the brush. There are a few tools here that you can use. I'm also enabling symmetry here on the x-axis, so I want to be painting on the right side and I want it to be copied on the left side, or the other way around. So now I just want to make sure that I get the most amount of weight painting here. Super red means that the influence is at 1, it's maxed, so that means the head bone will be giving its, like these vertices will be copying the head's position 1 to 1. So I want to make sure all the top of the helmet is painted red. And then the strap can have some parts of it weight painted elsewhere, because it might be following some mouth deformation. So when the character speaks, the strap will follow it wherever it goes. So after doing this, it doesn't need to be completely perfect. Like after you import the asset inside of the engine and you apply it on a character, you will see if there are any issues. At any point you can come back, fix them here, and re-import the asset, and everything will be the same. A nice practice is here you can go into weights and normalize all. This again puts all the weight painting from, if they go above the value of 1 and below a value of 0, it more normalizes them into 0 to 1. So I normalize them, and this might cause some issues to come back into the skinning. And this happens because maybe some other bone had influence on these specific influences, and now that I normalize them, this head bone lost some of the influence. So fix those issues. I can normalize once again, just to be sure, and with that the skinning of the helmet is done. What I want to do now is I want to go and copy that weight paint that I did onto the rest of the assets. So same as before, I select the source of my skinning, helmet LOD 0, I select helmet LOD 1, I go inside weight paint, transfer weights. The settings that we put here save as long as you're in the same session. If you quit and come back, they will change, so make sure you put them back. And I repeat the process for all of my LODs. So once that is done, I want to basically tell Blender that this helmet should be following this skeleton. Now I have the influences configured, these are the vertex group, but it doesn't know which skeleton I'm referring to. To do this, I need to add a modifier. Inside the deform tab, we find the armature modifier. We apply the armature modifier, and then in the object, we select our armature. And now the asset is pretty much skinned to this armature. We need to repeat the same process for every LOD. And once this is done, we will hopefully see this work. Now it's following the head position. Now the last part of this is we want to also make sure that the collider is following the rotation. Colliders do not carry with them any weight information, so we cannot actually skin the collider. What we can do is we can parent it to a specific bone, and it will always follow that bone's position. And again, since this is a helmet, I want it to follow a specific bone. Now if you open the armature and you start going down into the hierarchy, you will see all the bones and how the hierarchy is set up. And once you locate the head bone, this is where we want to be at. So if I select my collider, and then with shift select I select my skeleton, I go into pose mode. Now I have my collider, and I should have the head bone selected. this again. I select the head bone. Now I need to press Ctrl P. If I press Ctrl P, I'm basically telling Blender I want to parent this object I selected to the last object I selected. What we want to choose is bone. And after we select bone, we need to select this option here to keep transform. And now with this, it should also be following the rotation of the head. So now we should be done. One last thing we need to do is we need to make sure that we select everything that actually needs exporting. What this is our LODs, our collider. We need to select our empties that we brought in from the original source file, and the armature itself. So I select my LODs, my helmet, and the empties, and the armature itself, and I export. At this part we can start the actual mod. I can here I can create a new mod. Let me just helmet, very original. So we are now inside the editor. Here we can see the directory of our own asset. If I right click and show inside Explorer, I will see everything here. This is my mod pretty much. Here I want to start setting up my directory, so I will create an assets folder similar to what exists here in the base game. Then after that characters, and then I can go headgear, and this is where I could place my own asset. So now this is where I will export my asset. I've added my directory here, and some important settings here is that I want to limit the export to the selected items. That's why I selected it. And inside here in armature, I don't want to add the leaf bones. So I give my name to my asset, and I export. So now inside here in the file browser, if I go to my add-on and I go to the directory, I will find this FBX. I will need to right click and register and import. I will get this window, and since this is a model, import as a model. I will get this. Now I see that my LODs have imported correctly. I have 4 LODs. And I also have my collider. So now I see that my helmet is facing the wrong direction. I can see it once I opened it, and I can also see it here in the preview. I can fix this back in Blender, but it is way easier to fix it here. So I just add the rotation in the y-axis to 120 degrees, so it faces directly back to me. I import, and it is fixed. Now some things we need to do here. I need to export skinning. Now there is nothing here in the bone section because it has no rig imported. After I select this and I re-import, I will get my rig. So with that out of the way, I will import my assets. I have already exported them from Substance Painter. So we'll just copy and paste them inside the folder, and I need to do the same, register and import. This is taking a while. And one last thing I need to do. Here in the colliders we're getting an error. What this means is that the collider hasn't been configured. Inside the import settings, if we scroll all the way down, you will find the physics tab. here we will see our collider. In this specific occasion, we can open another helmet and check. So for instance this. Oh, we cannot. These are usually configured in the Fire Geo category. The layer preset is Fire Geo. And if we import, we will see that the problem is fixed. Here we select the surface properties, basically how hard the helmet could be, what kind of bullets can penetrate it or not. Here we see all kinds of armor. What we usually add is like this hard aramid 7.3. It could be a more realistic material for this helmet, but this is not this is outside of the scope of this bootcamp, I guess. So now we have our maps imported. We'll see there on the resolutions that we imported. If I double click on it, I can open it. And inside here on the import settings, I can limit the size that it will actually be in the game, because 4K is a bit too much for an asset. So for a helmet of this size, 1K is usually enough. So I change it here on the max size, and now the size of the texture has fallen. I will do the same for the normal map. Now the next part of this process is to actually just plug in my maps inside the material. Went a bit too fast. Just want the BCR map on the BCR slot and the NMO map on the NMO slot. We will do some more stuff here, but we don't need now. Now we can see that our asset has actual textures on it. So now to create an actual prefab that the character can wear, I want to create a map that I can test this on. So I just open the most basic of maps so that it opens as fast as it can, and then I go here and I create a world. I can create a subscene, so I will create a world of my own which is inheriting from this world, so I can add anything on top of it, because at the moment I cannot. This is a base game map, so I cannot add anything. So if I just do a subscene and then I save it, I can go inside my mod, add a new folder called world, and helmet test map. So here on the test map, I can start shaping my prefab. I can drop my asset here so I can check it. If you just drag and drop an XOB from the file browser, it will create an entity for you with a mesh object component and plug it in automatically. Now if you can notice it on the assets that exist on the base game. So if we go here on the headgear, yeah, Highpoly works. There is a normal version and an item version. What the item version is, pretty much, it's lacking a rig, because once if you place an asset on the world, if I take the prefab version of this asset, basically this is the item model. So instead of having the rigged model just placed on the ground, we have a separate entity, so we can also shape it differently. So for instance, a cap like this will look like this. This is its item version, and then the normal version that is worn on the character is this. So you can do a different model which looks that it's actually placed on the ground. Now I have already done this. Like for this kind of helmet is not very hard. Like I just need to get the helmet itself, just hide everything else, and just, this is my ground. I place it on the ground, make it look like it's normal. The geometry doesn't need to be the same between item model and actual worn model. The UVs would be nice to be if they could stay the same. So for instance here I can just delete the strap, it doesn't need to exist inside the model, that's an item. So let me go and copy the model. So now I've copied it inside the folder, you can see it here. I do the same, register and import. It's again flipped, export, no, I don't need to export skinning here, I just need to flip it. Import, now it's done. The same process here, item versions also need colliders. They don't really need it, but if you want the realism of it, you can. Like once you shoot at this, you will get decals on it. Once you step over it, the character will actually step on it. So it's nice to have. And again, the same process, fire geo here and aramid 7.3mm and re-import it, make sure all this is applied and my LODs are properly placed. So now that I have my item version and the normal worn version imported, I can start shaping up the prefab. Now again, if we take assets from the game itself, we will see how the inheritance is set up. All the helmets should be inheriting from the headgear base. Now using this we can see what parts have been modified. So if we go into the actual hat boonie prefab, we will see what's been added on top of the base headgear base prefab. So what this is basically the models have been configured inside the base load.cloth component. So worn model, item model, and inside the inventory item component, its name and description has been configured, and a bit of attributes about its volume inside the inventory. So we just need to go and do the same. So I can go on the headgear base, click this magnification icon here, and it will take me to the directory where this is placed at. So I can right click. No, I cannot. Right click, inherit inside helmet there. So I will name it helmet. Now it has placed it on the same directory as the base is at. So I want to go back. So I want to place it inside prefabs, characters, but not inside core. So we'll create a new headgear folder, and inside here helmet, and I can just drag it into this new folder that I have created. And now by dragging it into the world, I can see it. I can take out the settings I added before, so I can see all the attributes, not just the modified ones. So I can just start going in and punching in my own details. So once I place the asset here, it will take me to this entity instance. Now I'm editing the instance that exists into the world. Now I need to go and make sure I'm actually editing my prefab and not the entity that is placed in the world. So the first thing I need to do is place my model inside the mesh object. I can put either. Now we'll see my helmet has appeared. And then in the base loadout component, this is what actually will show up on the character itself. There are some stuff here that we could use, but since this is a helmet, none of this is really useful. For instance, the deflated model is used for some parts of clothing, so that it gets deflated when stuff is worn on top of it. So for instance, some jackets have that, so when a vest is worn on top, they get deflated just to fix some of the clipping. So I need to configure here my worn model. I will configure the item model, and inside the inventory item, I can leave these as they are for now. And if I need to, I can also change the position of my of the actions, where will they appear, but for now I think it's enough. So let's see if this works. So now I can interact with this item. If I swap, it gets onto the character. Now one thing that we noticed once we wore the helmet is that it is blocking the actual view. That is easily fixed through the material. So this is what I meant when I said we need to do some more stuff in here. And it should be these two settings. It is the allow user alpha bias and disable user alpha in shadows. So let's see. So now that is fixed. So another thing we can do is inside the inventory item component, because here I cannot actually see the icon for my helmet. And I can define an actual preview model. So if I add this, we might actually get an image. So now I can actually see the model here. And now the last thing that we could do is actually create a variant for this. So I can just duplicate this. And this is gonna be my open helmet. And now I just need to actually import the model. The same process as before. I have it here. I configured my collider, add the aramid material, export the skinning. I think it's also flipped, yes, so I flip it by 180, re-import it, and I need to configure it inside the proper one. So this is going to be my helmet open. Inside the cloth component, I go and I configure the proper model. And inside the mesh instance, I can give it a different name here so people will know. And I can also change the preview model here. Now it should be a different model. Yay. Now for the last part, we can do a bit more extra stuff. We can configure it inside the arsenal. So I think I have access to GM here. So if I go to US, I think it might be not checked. Systems, arsenal. What I want to do basically is configure my asset so that it shows up here, because it will not do by itself. Don't worry about these are some bugs that only happen in the editor. So in order to do that, we need to decide first on which function we want to configure this. I will configure it inside the US function, and I want to look for the US function configuration file. It's just called US. If I open this, and I scroll down a bit, I will find what I'm looking for. So what I'm looking for is basically this entity catalog. And inside here you will find all the items that are configured for this specific function. So they have the vehicles, the items. So if I go inside the items, I will find all the weapons, ammunition, throwables, etc. So what I want to do is configure it inside clothing. But since this is the original configuration file, it is locked. because this is the configuration file in the original game. So I want to just override it. Close it so it refreshes and open the overridden file. So now inside of my clothing I can start configuring it. Let me close all this up so we have a bit more visibility of what we're doing. So we can take an example of how another asset is configured. They basically configure the prefab that we just created, and then some arsenal data, basically what kind of item it is, supply costs, etc. So if I hover over this, I can see what kind of configuration it is. This is an SCR entity catalog inventory item, so I will add the same. So if I find my metal helmet inside my mod, prefabs, character, headgear, I place it here, and then in the entity data list is where the arsenal data exists at, and then again I see what kind of item is configured as here, so I don't need to do mistakes that are easily avoided. It's a SCR arsenal item. Item mode, it is headgear, and this should be enough. So if I spawn again an arsenal here, this is unfortunate. Let me delete some of this so that we don't have any. Is this it? This is not it. Must be something I'm missing. Let's do a quick restart. It always helps. guess I'm sorry, I should have rehearsed this part a bit better. But the gist of the story is done. What we wanted was basically to figure out how to import a model. We went through the process of how this was created. So we're back again, trying to figure out why the helmet isn't showing up in the arsenal. Like a nice clue we have is it doesn't even show up in the vicinity, but I should be able to pick it up and equip it normally. So what we can see here is if we compare it to another item, another prefab that is being used inside the game, we can find a fault here. Inside the inventory item component, the attributes are set up wrongly. In the normal item, in the boony, let's say, we can see that the extended attribute collection is being used. That's the SCR underscore, and we're using the base one. So after fixing that, we should see everything working normally. To fix this, you just right click on it, press the change class, and here at least the only other option you will get other than the attribute collection is the SCR underscore attribute collection. So with that fixed, we should now be seeing the helmet in the vicinity, being able to equip it, and seeing it on the character as well here. And if I spawn an arsenal, everything should look correct. And here's the helmet. So that was it. It's an easy thing to get wrong. I'm going fast. Like the best bet is always to compare yourself with prefabs that exist on the base game. There is no way that something is wrong with your asset. It's usually the configuration and how it was done inside the mod. So try to backtrace your steps, see how the base game assets are composed, check it's a component by itself and see what they're doing in there. Again, a nice trick you can do is here, so only modified properties, and then uncheck this so you can see everything. And here you can go and see exactly what changes have been done from the base to this prefab, so you can see exactly what happened. So here you see inventory item component, the attributes are set to the base ones, but the moment we go to the hat bunny, the attributes have been switched up to the SCR, the extended class. So yeah, this is a way to check if anything is wrong. It's always safe to double check stuff. So yes, sorry for getting it wrong, but yeah, going fast makes you do these mistakes. Yeah, take care.